So what I'm going to do today is, this is the game plan. I will do a couple what I call easier ones, and then I will show you some that are a little harder to classify. Okay? And so here we go. Page 8. Have a highlighter or two ready. So every single triangle, this is review, right, should have a first and a last name. The first one is either acute, right, or obtuse. And the second category you can choose from equilateral. What's the other one? Isosceles or scalene. This is if it says classified by side and by angle measure. Like so, these are the two that you have to pick from. So let's look at it. One thing you should notice right away is that these two sides are the same. So when it comes to side length, I will say this is an isosceles. Okay. When it comes to angle, I have to do a little bit of digging. So guys, when there are angles and you can find more information, do it. Do it. Okay. So if this side has a 25 across from it, you can bet that the other side that measures the same will have a 25 across from it as well. Guaranteed. Okay. So given that, we can now easily find the third angle. So we're going to go 180 minus 25 minus 25. This is 50, right? So we're taking 50 away from 180, and we're left with 130. So this angle here, maybe I'll use a different color, but this is 130. So in terms of angle, you have one angle that's bigger than 90, which is obtuse, right? It makes that triangle obtuse. So there you have it. Okay, that would be your obtuse isosceles triangle. Maybe I'll do pink, this color, whatever your color is. And right, so I kind of have one per category. By side length and by angle, it's classified. Right, one more. And then I'll do the harder ones. Or if you want me to do another one, sure, I'll do more. But look at this one. Two sides are the same. Okay, so most likely isosceles. Okay, so I'm just gonna go ahead and say that already. Isosceles. Isosceles. Okay, and let's do some more digging. We know. Make sure you look up here, right? Don't look into your phones or anything. We know that the angles across these two sides, let's see, they're going to be the same, yeah. All of them have to be 180, right? So I know that this is going to be 50-50 in this case. That's the only way that works. But to show the math, I'm going to go 180 minus the 80. And what do I do with the rest? I split it in half. Okay, so I get 100 divided by 2, that's 50. Let's use our red pen or whatever and just say this 50 goes here and here. That's what I've determined, right? That both of them are 50. None of them is bigger than 90. I don't even have one that is exactly 90, so it's acute, right? Oh, I just used up my space here. I will just do it like this. It doesn't really matter. You just have to have a first and a last name for that triangle, okay? I hope that's okay. I hope it's not too overwhelming. What I'm going to tell you is try to find all the angles if you can. It gives you a lot of information, okay? If there are no numbers whatsoever, then obviously you're stuck with just looking at the diagram. But if you do have numbers, do some digging, okay? So I'm going to just make sure you don't mix this up and just cut it right here. I don't think it hurts to do more of these because you're not. So no numbers, no values. We just go by the diagram. So the first thing I would like you to notice is that these markings tell us that all three sides have different lengths. So this is scalene. And some of you did the homework, you looked at the answer key, you're just, sure, you can look whatever you want to do, it's fine, but you should pay attention still if you haven't done this. This part right here, I'm just going to focus on this angle. By the looks of it, that's an obtuse angle, right? So the whole triangle turns into an obtuse triangle. And last but not least, this one here, focus on this one. If there's a right angle, it is a right triangle for sure. So that's the first thing. Right, and then the next part, you have to do some digging. You've got two angles, actually very easy here. It's 180 minus 90, right? This one, minus 45. You end up with 45 as well. What does that tell us? If two angles are the same, two sides will be the same, right? So I know that this side will be the same as this side. Okay, so isosceles. Okay. I feel like I forgot how to write over the break. Okay. Isosceles, right? So because of the side lengths, how did I know the side lengths were the same? The angles told me that. Okay, the angles give it away. The angles cannot keep a secret. They give everything away. Okay. All right. I hope you're doing all right. I hope you're writing this down. And there is no one way to do this. You can approach it in various ways, and that's fine. Next. You're still writing this down. Go for it. Go to page 9. What do I have at 9 here? I'm just going to look. I want you to classify. Hands up, who has done page 9? It's completely done. Good for you. Everybody else, you should work on 9. And if you're done 9, keep flipping through the pages and see if there's something you find that you haven't done yet that asks you to classify a triangle. Because they get a little trickier. If you're up for the task, you can do that, right? So just keep going. I will give you a little bit of time, not much. I want to get to the harder ones in a bit, so let's tackle some of these. So each one you're supposed to classify each by angle and by side. Okay, so that's a classic way of doing that. I think this is safe to say that because of that 115, we're gonna go with obtuse right away. You can't have more than one obtuse angle, right? So this triangle is obtuse, and because of the markings, it's isosceles. So this one actually, as it stands, it's good enough. If you found these two angles, which is 42.5, I believe, there's nothing wrong with that. I would always encourage, hey, find stuff. If you can find stuff, go for it. What's that? No, use a decimal. That's fine. A lot of, perhaps in previous grades, they may have asked you to always round it to a whole number, your final answer, when you use SOHCAHTOA. But in this case, I would say keep it decimal because that's more accurate. This one here, the markings give it away. All three sides are different, so this is scalene. I'm assuming that angle right there, I'm just going to assume it's obtuse. That's all I have to go by. Okay, so this triangle turns into an obtuse triangle. Obtuse scalene it is. So fairly straightforward. What about this one? Here I would argue it's not enough to just leave it as is, right? So if this side and this side are the same, right? Then if this pair this up, right? This goes paired up like that, so that means that this should be a 45 here. Immediately you can just go ahead and figure that out like that. Which means that I can now find that third angle, and some of you have already done that. So I'm going to go 180 minus 45 minus 45. That leaves you with 90 degrees. So you can actually put a box in here and say, hey, that's a 90 there, which means that you can say it's a right isosceles. The isosceles part you could have done right away, for sure, but the right is something you would have had to do some digging. If you would have told me that this is an acute isosceles, you would have lost the mark for getting the angle classification wrong. I think I'm going to do one more. That's it for this section. The key is online, so you can go check it out. Here we have that this side is the same as that side. How do I know that? By the measurements. And I have a 70 here. I'm going to figure out, because these are paired up, I know these are the same because the angle that isn't across the equal sides is given to me. I need to do a little bit of work. So 180 minus 70. Make sure you do this first, then you split that in half. That's 110 divided by 2. That is 55 degrees. Okay, so now I know that this is 55 and this is 55. And why did you do that, Mr. Dirksen? Just to make sure I know they're all acute. Every single angle is less than 90. So I will name this acute, and what else? By these two measurements, it's isosceles. Mr. Dirksen, shouldn't we have found this last side here? It would have made zero difference because I know that this side here is going to be bigger than the other, these numbers, because a 70, right? If this is a 70, then this side will be even longer than the ones before. But it wouldn't change anything. It wouldn't change our answer. To be honest, 5, I shouldn't have added that yet because I haven't done. Here you could have used cosine law. I don't know if on the key I did that, but that's actually what I want to talk about today a bit more. Anybody figured out 6? Question 6, this is the reasoning. All 60s, yeah. But here's my reasoning. You're with me, right? These two sides are the same, which means that the angles across here would also be the same. This is 60, so I'm going to go 180 minus the one I'm given. Divide that in half. That's 120 divided by 2. That is 60. So that means that this is 60 and this is 60 as well. And this should ring a bell. It's like, oh, they're all 60. This is an equilateral triangle. So much fun, eh? Not. Mr. Dirksen could have done this. Acute, yes, that's fine too. Saying acute equilateral is fine. It is actually correct. It is correct to say it that way, but the province does not require. Okay, we'll keep going. I need you to be able to sketch, because I'm going to ask you in many ACs and as well as on the test, I'm going to ask you to do this. And it's very easy if you just know what you're supposed to do. So this is on page 11. Here it is. I'm asking you to graph or sketch. It's just a sketch. Okay? Sketch an acute scalene. Acute means all angles are less than 90. Write that down, right? That's what the acute part means. I'm going to zoom into just that one so your eyes don't hurt. There you go. The acute part means, hey, all angles have to be less than 90. That's a requirement. And you need to make your intentions known. Okay? You can't just be like, yeah, this kind of looks like it, right? Scalene means all sides / angles. It doesn't just, like, you can have either or. but all sides slash angles are different. So my key, I don't know if I had that on the key, but this is like how I would approach it today. So this is how you do it. I'm gonna just, the classic triangle where all sides are different is this for me. It's a little bit offset, like it's not perfectly centered, and every side is a little different in length. Okay, so something like this would do the trick, but it's not good enough. So here you have to do a little bit of playing around with numbers. I'm gonna make this one up here. This was the biggest angle I have. I'm gonna make that 80. And then you have to make all the other ones different, because if all of them have to be less than 90 and they all have to be different. So what should I use here? 70? Sure. What does that add up to already? 70 and 80? 150, right? So I have 30 left over to place over here. Right? I will just make a note here. Sum of triangle is always to 180. So if you just put random numbers in there and it doesn't add up to 180, you're still not going to get the full marks. Okay. So can I leave it like this, Mr. Dixon? Is this good enough? Well, let's see. Are all angles less than 90? Check. Are all the sides going to be different? Yes, because all angles are different. Check. Right. But if you want to make absolutely sure, all you do is this. Then you're absolutely sure. You're telling me, hey, all three sides are different. Okay. So that's what I only need you to do this. You don't have to write a whole bunch of stuff. You just have to make a diagram. Next, right beside it, obtuse isosceles. Let me see. Is this good? You can see that, right? I'm going to leave that. Some of you are still writing. Obtuse. One angle is greater than 90. That's what that is telling me. Isosceles, two sides slash angles. Here's the symbol of the day, okay? Oof. And I'm cutting off, right? Hold on. Two sides or angles must be the same. How do you make that happen? I always make mine kind of look like a roof of a house, usually. So because it's isosceles, I want to make both sides kind of appear to be the same length. And then you just connect the bottom like that. To be honest, the numbers will rule. If your diagram kind of looks wonky, but your numbers are right, you still win. Okay? You always win if you put the numbers in that belong there. So obtuse would mean I will make this my biggest angle. What should we make it? 100. Okay, sure. If this is 100, now I need to make sure, so this is my obtuse part, check. I want two angles that are the same, which for me are going to be these ones. It has to be, if you pick 100, then this has to be 40 and 40, right? Because that adds up to 180. If you had picked 110, or let's say you picked 120, you have 60 left over. This would have been 30 and 30. Okay, so just do some, pick simple, easy numbers. And just to make absolutely sure, I'm going to say, hey, you know, these two 40s, the sides that are across from them are the same. So now that is an obtuse isosceles triangle. Take a moment. This should not take you very long, to be honest. Take a moment, pretend this is an AC right now, and try to do the other four. I will probably give you enough time to do two real quick, but if you get to do all four, good for you, okay? And then I'll take it over to the harder ones. So if you, I hope you know what to do. Obtuse scalene. Watch this. I already worked with an acute scalene. Now I need to make an obtuse scalene. You could honestly make the exact same. Instead of 80 up here, I'm just going to slap on a 120 as my biggest angle. My key online may be different, that's fine. And so this one would be, I don't know, I'm going to make this 50. So that's already 170. So I need to make this 10. That's technically all you need to do, right? So 1, 2, I'm just going to do that on the sides there. You could also put measurements, side measurements, but I would just leave it. Right isosceles, how in the world would you do that? You can do it as a roof again, like this, where my 90 is up top. If this is 90, then I need to split the other 90 equally. So this would be 45, 45. And you can also just do this. Okay, that would have done the trick. Some of you might have wanted to graph it like this, where the 90 is over here. And then you just make the markings on the sides here. That is also correct. And acute isosceles, I think I'm going to leave those for you. They're online. If you want to check whether or not you did that right, you go for it. Now to page 12. Let's keep going. So this is going to require a little bit more work. Okay, so make sure you wake up. And so what I will write down here, I think, to scare you, I'm just going to say harder. And it's not going to be that much harder. It's just going to take a little longer to get to the classification part. So you've got this triangle that you're supposed to classify, but you have no angle inside. I'm going to grab a highlighter and just let you see it, right? There's a straight angle here that is cut off by the base of that triangle, basically. So if this angle here is 120, you go ahead and make that. Then what would this have to be here? We know it's 180, right? Across, so this would have to be 60 degrees here. I'm going to use a different highlighter. I'm going to move over to this one. So if you have a straight angle there, right, which is kind of cut by the one side of the triangle, let's make it bigger here. This is 150. If that's 150, is it a bit blurry or is it just me? Then this must be 30, right? You can write it inside if you want. So now we have, right, our angles, the two angles inside. Let's go ahead and find a third one, okay? Let's find this one here. Should I say this? This was my first step, this was my second step, and this is going to be my third step. 180 minus 60. Some of you are doing this in your head already. 180 minus 60 minus 30. This is 90, right? And I'm taking away from 180. So I'm left with 90 degrees. It doesn't look like it, does it? But this is technically a 90 here. So you can put a box there like that. I know the graph is terrible, but we're just going to go by the numbers here. So I can confidently say, because of that 90, that this is a right. And what else would I add to it in terms of the side lengths? Yeah, I heard it, but let's see if somebody else can. In terms of the side length, what would I say? Scalene, right? Scalene, because all angles are different. Right scalene. Bingo, right? I know this. I will just write this. I know this because I'm just shortening because like that. Because all angles are different. If you had 230s or 245s in this case, then yeah, it would be an isosceles. But I don't. Okay. Next. So this is a very special case where you had to bring, yeah, you use the angles outside to bring the inside, right? Next, here, this one. We have this 90 here, and we have this angle. Let's find the third angle because it's so easy to do. And that gives you 49 degrees. Okay. So this is 49 here. And just by looking at it, I could right away tell this is a right triangle, so that's not disputed here. But what is it in terms of the side length? Well, Mr. Dirksen, I can use sine log because I have a pair here. And I can find that one, and I can find this one. Don't bother, because all three angles are different. It's scalene. You're done. Okay. All angles are different. I'll make a all angles. Watch this. I go congruent, but I cross it off. Like the angles are just not congruent, so I can just say, hey, it's scalene without any further examination. You're done. So much fun, eh? You love this unit, just like all the other ones. Okay. What about this one? Let's say tomorrow I give you an ACs. I classify this one down here. Well, I have a 90, so can I start with right? Absolutely, you can. I would start with that for sure. What about this one? Could you say isosceles? Can you say equilateral? There's no such thing as right equilateral because they all need to be 60. It's either scalene or isosceles. There's a chance that this side down here could be the same as this one, right? If there's a right triangle and you have two sides, what can you use to find the third side? We did that yesterday. We practiced it. Pythagorean theorem. This is your hypotenuse. This is a leg. This is the other leg. Let's quickly, if we had one more angle given, we wouldn't have to do all of this. Okay, but we only have one angle and nothing else. So leg is equal to, yes, minus, that's right, hypotenuse squared minus the other leg squared. I'm just going to quickly find out what that is. $737. Take the root of that, 271. So this side here is 2.71 meters. It's close, but it's not quite. Right? It's almost 2.8, but it's not 2.8. So it's, in this case, it is scalene. If we had had one more angle, this would have been unnecessary, this step that we just took. Right? Can I just make a note of that here? only one angle given at the top of this. Okay, that should kind of give away why we had to do so much work because of that. Maybe I'll highlight that even. Only one angle is given. And I'm going to end here. I'm just going to give you this one example, and then I'm going to give you the rest of the class to work through it. Use it, right? I kind of took it easy on you today, right? I reviewed some of the homework because we were just coming back from the break, and sometimes it's okay to go over that. So let's go to page 13. And let's talk about, this is probably the most work you'll have to do. And I will highlight the fact that, right, using sine or cosine law to classify triangles. Okay. So let's see what it reads here. At times, there will be enough information given to classify the triangle. You must use all tools you have learned about them and to find out more. So anything you know about triangles, use it to find out more information if needed. So classify the following triangles, right? So you have this one to the side here. And what do you notice? It isn't a side, side, side case, right? Side, side, side. It's something that I would like you to make note of. And just by looking at the side lengths, you can immediately say that this is what type in terms of the side lengths. They're all different. It's scalene. So I'm going to get ready because it's asking me to classify. I'm going to already write down the scalene part. However, do I know what I need to know to say whether this is acute, right, or obtuse? In terms of the angles, I have no angles whatsoever. But it's a side, side, side. We can use cosine law to find the angle. Okay. This is the one I want you to focus on. I want you to focus on this one right here. Okay. I'm going to focus. This is the longest side. I'm going to focus on this angle right here. Okay. Why am I focusing on that? I'm asking if that's the largest one, if this is the longest side, then this is the only one that could possibly be obtuse. Would you agree with that? It's across the longest side that could possibly be obtuse. I will ask the question here, is it obtuse? Question mark. And how about we also write down that this is the longest side, because I think sometimes students miss that. Okay, let's just write it inside, longest side. So we have to narrow it down. We have to say, like, is this, if this is an obtuse angle, then the whole triangle is an obtuse triangle. If we do the math and this is less than 90, we have ourselves an acute triangle for sure, because if this is the biggest angle that's less than 90, then all the other ones will be less than that as well. It could also turn out that this is exactly 90. Okay, when you do cosine law, you do the math, and all of a sudden you get exactly 90, then it would be a right triangle. Okay, so let's do the math here. Cosine of y. Do you remember how to do this? If you did the review, most likely you will. But the way cosine works, if you're trying to find the angle, there are two sides you add and then one you subtract. So you go minus the side that's across the one you want. So this would be minus 6.1 squared. And the other two sides, you go 4.9 squared plus 3.5 squared, always squared, everything on top squared, and down here is 2 times 4.9 times 3.5. Grab your calculators and do some typing away here. Just to stay awake, right? Okay, so the top, when I enter the top, I get negative 0.95. Anything stick out there with your answer? When you do the top, it should be something that sticks out to you, Faith. Exactly. Yeah, it'll be obtuse, it'll be greater than 90 because of that. You're guaranteed that it will be, so watch what I'm going to do here in your notes. I'm going to go over and make an arrow and already make my conclusion before I even finish this question. I'm going to say obtuse. If your sign is negative, you know it's obtuse. If it's positive, it's going to be an acute angle. Okay. Let's finish this question though. Angle Y is going to be cosine inverse of what I get when I divide these two. So negative 0.95 divided by 34.3, that's this. A very small number. You just go dot, 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 shift cosine to call the inverse. That's 91.59 degrees. Do we care about the other ones? No, we don't care about the other ones because as soon as we have the bigger than 90 part, case closed, it's an obtuse triangle. So sometimes you can close the case without filling in the entire triangle. Okay. Is it possible? Yes, it is possible to do the other ones. But that's that. Okay. And I'm going to add a box in here for you to know. If, write down if cosine of a negative will always give you an obtuse angle. Greater than 90 degrees. Let me zoom into that if I can. Cosine inverse of 0 right angle. Cosine of positive gives an acute angle smaller than 90 or less than 90. I'm going to box that in. going to say this, homework, page 13 to 16. And you can start now. I would strongly suggest you do so. Right, so I wrote down the homework right on the side here. I would say the question right under this, keep going. And I would post the key. You could use sine law, you could use cosine law. It depends. All right, just gonna make sure. I think the key doesn't include this question here. So if you want to take a picture, that's what I did. That's the work that went with it.